Hi, welcome to your lesson on sector area. You may remember not too long ago in Unit 1, we looked at arc length. Now we're going to look at sector area. And it's done in much the same way. This is a sector, by the way. Okay, let's jump into it. What is a sector? I have a pizza here. I wonder why. Let's take a look. A sector is a portion of a circle lying between two radii. So here's one radius, another is two radii, and the subtended arc. This is the subtended arc. So this is what a sector is. It's like a slice of pizza. That's why I have this picture here. So here you can see many sectors. 1, 2, 3, 4, 5, 6 different sectors. The important thing is when you draw a sector, it must have a corner at the center of the circle. And that's what we saw here. So this one is also like a slice from this circle, but it doesn't have a corner at the center. So this is called a segment, not a sector. Okay, so that's what a sector is. That's easy to remember, right? Before, we talked about an arc. So an arc was just a portion of the circumference, and now we have a portion of the area here, right? So now, if we're thinking about pizza, what would the arc be? Well, the arc would be you eat that piece and you just leave the crust. That's your arc, right? So sector is your slice, and your arc is just the crust here, okay, the edge. Okay, there's some crust for you. Everybody loves pizza crusts, right? Okay, so now let's go back to the same way we looked at arc lengths. We're going to approach a sector area the same way. So what portion of the distance around the circle have we gone? If we create an angle of 180 here, what portion of the pizza or the circle do we have? Remember, we found that just by setting up a fraction, right? We have 180 out of a possible 360. It gives us half. And of course, you're looking at this and you're saying, I know this is half. But we need to remember that we have to begin with this low calculation. That's where the half comes from. It's a fraction, 180 out of 360. Okay, so therefore, let's look at circumference and area. If our circumference is 130 for this whole pizza, the whole perimeter or distance around it is 130, what would be the arc length? So what would be the length of that? And likewise, if the whole area is 280, what would be the sector area, which is this sector here? So what would those two numbers be? I hope that one came easily, and also obviously we have half the circle here, therefore we'll have half the circumference to do this arc, and we will have half this area to find this sector area. So we just did half of those. Okay, next one. What portion have we gone around this time? What portion of the circle do we have? 120 over 360 is 1/3. Okay, let's do the same thing with circumference and area. So let's say circumference is 210. How long is that arc? And let's say the area is 480. How big is this sector area? Okay, in this case, we're doing 1/3 of those numbers. 1/3 of 210 is 70 for the arc length, and 1/3 of 480 is 160 for this sector area. Next one, what portion do we have here? This time we have 60 out of 360, which is 1/6. We have 1/6 of the circle. Therefore, circumference, let's say it's 66 the whole way around, and we want this arc. And let's say the entire area is 240, and we want just this sector. Go ahead. Okay, 1/6 of 66 is 11, so this arc length would have a length of 11. And if the whole area is 240, 1/6 of that is 40. So we have an area of 40 here out of the possible 240. Let's keep going. Hey, when you're doing something right, let's do a little bit more of it. What portion do we have here? 40 out of 360. Simplify that to 1/9. Okay, we have 1/9 of the circle. Excellent. Circumference, let's say the entire circumference is 63. How long is the arc? Let's say the entire area is 54. What area do you have in this sector? Go. Okay, 1/9 of 63 is 7. 1/9 of 54 is 6. Great job. So let's take that and basically create a rule for sector area. We're on a roll here. We know how to do it. What's the rule? What's a general rule? Well, let's say this whole area is 224. We want the area of sector ACB, and let's assume this is a 90-degree angle here. So therefore, we have 90 out of 360, which is 1/4, and we do 1/4 times 224. And that's 56. Okay, same process we've been using, but how does this get us closer to a rule? Well, let's try. Let's generalize a rule. So what do you think? What should the rule be if we didn't know the angle? I mean, if the angle was unknown angle theta or some unknown angle, how would we create a rule to represent this? Well, the rule could just be sector area equals something times the full area, right? Because we're always multiplying the portion we have by the full area. So what is that? What goes in there? Well, that is theta, or the unknown angle, over 360, right? That's how we find it. We find the portion. So we find the portion of 360 that we have, and we multiply by the area. Let's take that area formula a little further. So here's another one. We should all be aware of our piece sign here. And in piece sign, we're going to assume that this is 1/3 of the circle, okay? So we're looking for the area of sector ACB again. We have 120 out of 360 because we're saying this is 1/3 of the circle, so it's 1/3. Now, 1/3 times 147 will give us this area. We have this, but again, trying to generalize the rule, we already got to the point where we had something times something. I want you to take that rule we just wrote a little further. Instead of area here, what are you going to write? So we do have theta over 360, some portion, like we do here, times the area. But what is the area of a circle? Well, it's pi r squared. So there we have it. That's where it comes from. We have the area of a sector. It is found by using this formula, and it's just a portion of a circle times its full area. So there is our formula. Let's apply it a little bit. So just going back in time again, I want to show you that this resembles the arc length formula. When we were finding the length of an arc in the last unit, we did the same thing. We found a portion of a circle, and we multiplied by 2 pi r. 2 pi r is not the area, it's the circumference, because remember, an arc, for example, here to here, is a portion of the circumference. So we're doing a portion times the full circumference. But now, with sector area, doing the same thing, notice, see, we find the portion, but instead of multiplying by circumference, we're multiplying by the area, because sector area is a portion of the full area. So just remember that little difference there, and if you really ponder it, it makes absolute sense. Circumference, area, let's move on. So arc length is part of the circumference of a circle. So if we have a circle, and we go like this, and we know that angle is 165 degrees, and this radius is 8, we can find the length of this arc here because it is a portion of the full circumference. So let's try it. Use your arc length formula. Okay, so arc length formula, right? We find the portion we have here times the circumference. Let's put in the numbers. We have a portion here found by this fraction, 165 degrees out of a possible 360. That is the portion we have, and then times the circumference, 2 pi times 8. Multiply all that out, and you get an answer of 23. So this arc has a length of 23, whatever units we are using here. Now try sector area. Okay, the area of a sector is part of the area of a circle. So here's a circle. Is that the same number? Yeah, we're going to use the same one we just had. So here's 165 degrees, 8. And to find the sector area, we're going to follow the same process, but again, we're doing area instead of circumference here. So what portion of the full area do we have? Put in the numbers and see what you get. Okay, we're looking for that area. 165 out of 360 is the portion we have times the full area, and we'll know what this is here. Okay, calculate 92.2. Okay, pretty easy to use formulas. So I hope you feel comfortable with that example. Let's apply this to just areas now, because this lesson's about areas, but I wanted to compare the areas in this sector arc lengths because that's important to see the relationship. So check these out. What are these here? Well, these are, I believe this photo is taken from a desert in Libya, and obviously it's difficult to grow crops or plants in deserts, but they've found kind of a technique. Obviously, if you put water somewhere, you can grow anywhere, even in the desert, right? But you want to be as efficient as possible with your water usage. So what they've done here, they've invented a very simple machine that allows for a very efficient watering, but it's done in a circle for some reason. Why? Let's take a look at what the machine is that waters these plants. So it looks like this. Imagine something, there's a pipe for water supply. Okay, it's fixed in the middle. This would be like the center of the circle right here. This is in the middle, and then you have the pipe here, and the water can spray out of here very efficiently. All right, and this thing has wheels on it. So this thing actually has a motor. It turns So imagine you have something in the center here, and there's this long arm like we have here, and it's just turning around and around. It's creating a perfect circle because this thing is like the radius of the circle. And we have a perfect circle with very efficient use of water, and notice how the crops grow very well in that area. No wastage of water, and that's what you need to do in countries like this that have deserts. So here's the problem. A crop sprinkler irrigates a circle with radius 5 meters. Find the area of sector BAC. So what's the area of this? That has a central angle of 120. Okay, so you're just using your area formula. You're saying, well, that's not what is the area of the whole crop? That's not what we're interested in. We just want to know this area here. So find it. Okay, we're using our sector area formula. What portion of the circle do we have times the full area? 120 out of 360 times this. And we can find out that we are talking about an area of 26.2 meters squared right here. Let's try another one. Try this one here. All right, classic. We often have these problems where things are turned backwards on us, right? Here we are told the sector area of BAC, and we are told it is 30 pi centimeters squared. So this has an area of 30 pi centimeters squared. And we're given the radius, and we don't know the angle. So the angle is what we need. So use the area formula for sector and solve backwards. Okay, so here's the area formula. We're going to replace theta with x. That's the unknown angle, so we don't know what portion we have here. But we do know the area, so we substitute it here. And then we put pi r squared. So we have this. Now let's solve this. See if you can do it in one step. How do you move everything to this side, leaving the x by itself? Well, you can multiply by 360. So notice there it's on top with the 30 pi. And then you can divide it by all this, and that's why that ended up underneath the 30 pi here. Okay, solve that. The pi's cancel, and you get this answer here. So we were able to find the angle. That central angle is 63.9 degrees. Looks perfect for what we see there on the diagram. And now let me show you one more thing before you wrap up with a couple problems. So we've been talking about sectors, and they are slices of a circle, right? If you have a slice that's under 180 degrees here, it's called a minor sector. And if you have a slice that's greater than 180 degrees, like this one here, it's called a major sector. Okay, that's important to know. Now, also, I'm going to recap something I mentioned earlier, which is, here's a sector, which is a slice that goes all the way to the center, right? And here is a segment. It's also a slice of a circle, but it is a slice made in any part of the circle, right? You just connect 2 points in the circle and you have a segment. So the next problem is going to be dealing with a segment. Let's see if you can figure it out. So here we have a sector AOB, okay? So this full slice would be the sector, and it has a radius of 4, central angle is 75, and it says, determine the area of the segment, so this green one here, enclosed by chord AB and the subtended arc. So you're looking for the green here. Okay, this is going to be done in steps, and I want you to think about some things you know. You know how to find the area of the full sector. We were just looking at that formula. So maybe begin by finding the full area of the sector. And then think about, if I have the whole area of the sector, how do I find a segment? I need to remove this triangle. And you do know how to find the area of the triangle. That was our last lesson. So how about combine those two skills, see what you come up with. Okay, so here's area of a sector formula. Putting in the values we have, we can find the area of this sector is 10.47, or let's say 10.5. So that's the full thing there. But now we need to remove this triangle from that area so that we're left with just a segment. So as you may remember, the area of a triangle, we have this formula using sine. We do half, and then this side times this side, and times the angle in between with the sine of it, right? So that's the area of a triangle. We just learned that in the last lesson. That area turns out is 7.72, or 7.73, sorry. So now you just subtract those two, and it gives you the area of the segment, the leftover part, the green. Great job. If you're able to do that with no support, you have a good understanding of how to put our skills together. And let's end here. Look at this, the world economy, shown by what percent of the economy each country has. You can see the US has 23.32% of the world economy. The rest of the world here, Japan has a big slice, China, of course, a big slice, and on and on. Interesting diagram. Are those segments or sectors? Well, neither, but I thought they kind of relate to what we're talking about here, so I wanted to show you that. Great job. We'll see you soon.